Hi everybody, I'm Marcus Foss from AXO, and today I'm going to tell you how efficient and effective agile software projects generally look like, and how this fits together with certain project management methods such as Scrum and Kanban, or process models such as the V model XT. In the video on Agile and the Agility Profile, I explained that virtually all efficient and effective agile software projects have three key characteristics. They have an explicit preliminary phase to define the essential basics, not too much but also not too little. Then of course the actual development and detailing takes place iteratively, and central team internal roles, especially project manager or architecture owner, are explicitly defined and filled with experienced domain experts. With this, we can now define a universally applicable template for efficient and effective agile software projects, which we call the basic process model. This is the project. As I said, it makes sense to define and assign the appropriate team internal roles right at the beginning. At the beginning, we then have the advanced basic conception, which is sometimes also called envisioning. Only then does the actual iterative development begin with an individual set of iterations or sprints. In the basic conception, we only clarify the essentials. That is, we only create a rough overall plan, for example on the level of larger work packages or epics, which we roughly put on the timeline. The analysis of the requirements and the functional specification based on them are also only roughly done here for the time being. And we define the architecture of our solution to the best of our knowledge and belief in terms of a rough design, or, as Tom DeMarco once called it, a framework for change, in which the supporting framework remains as stable as possible while the details evolve. But the decisive factor here is no big design up front. Each iteration then starts with an individual detailed planning of which requirements or features are to be addressed. The main part of the iteration is then the detailing of these requirements, an appropriately fine technical detail specification and a technical detail design, and in particular, of course, the actual creation of the code, including tests at all levels. A project is technically more or less capable of regularly deploying the current status, either into an acceptance test environment or directly into operational use. At the very least, however, this must take place towards the end of the iteration as the basis for an acceptance test by the user or customer by providing feedback on the results to date. The final step is a review of the results and a retrospective on the process. The iteration is flanked by continuous management of the scope, risks, and all relevant stakeholders. If there has been a formal offer and negotiations prior to the project, a final phase is required to conclude the project after the last iteration has been completed, in which the user or customer finally tests the result and accepts it on this basis. Possibly after the elimination of any outstanding errors, and or under the condition that any remaining errors are still eliminated as part of a warranty. The project then ends with the rollout and a formal project conclusion. Larger projects, however, should not be planned and executed as one large whole in the way described above. Rather, they should be implemented in the form of a number of releases or stages that can be planned and executed in a meaningful way, each of which comprises all the phases described up to this point, starting in each case with its own bidding and negotiation phase. The reason for this is that it does not make commercial sense to agree on projects that are too extensive. And a staged introduction of new software also reduces risk compared to the famous Big Bang. We can now also map all of the basic best practices to this basic process model. General best practices are: we clarify only the essentials up front, in specification and design as well as in project planning. We only detail a requirement when it is our turn. We document appropriately and only what is necessary, both in the detailed specification as well as in the detailed design, where we primarily record our design decisions. We realize parts of the software as early as possible, which we integrate and test immediately, in order to put them into operation afterwards in whatever form, to determine the customer acceptance or the achieved customer benefit. We regularly ask ourselves what we have learned. We consciously adjust to changes and take them into account on an ongoing basis. And we promptly incorporate into the next iteration any new insights gained with it, especially about what really benefits the customer. And as additional efficient techniques, we intelligently combine functional specification and test case creation and specify details directly by means of tests where it makes sense to do so. Extreme form, test-driven development. We regularly revise our software, refactoring. We sometimes work on the same software in pairs to exchange know-how and to ensure code quality, pair programming. And we automate testing, integration, and deployment, and then do this continuously. Test automation and continuous deployment. And how does this fit in with methods such as Scrum, Kanban, or the V-Model XT? The basic process model is a general template that can be further concretized by all the methods mentioned. Scrum is a project management method widely used, especially in the software industry. It is very simple and clearly defined with only 3 roles, 3 artifacts, and 4 rituals or events. If we want to apply Scrum, we should additionally define the necessary further roles, product owner and Scrum Master within the team, in addition to the team external roles. We should use the first 1 or 2 sprints for the basic concept. The rituals at the beginning and end of the sprints, that is sprint planning, review and retrospective, fit more or less exactly. Daily scrums have also proven to be efficient and effective in many projects, provided they are conducted in an appropriately short and crisp manner. Likewise, using the product backlog, sprint backlog and product increment artifacts to organize requirements, and the emerging solution is a purposeful concretization. Scrum is a method that we can recommend for many project contexts. Kanban originates from the manufacturing industry and aims to optimize the flow in the production process. For some time now, Kanban is also very popular as a management method in software development. The 4 basic principles and 6 core practices of Kanban are either already inherent in the basic process model, or as in the example visualization of the workflow, Kanban boards mean target-oriented concretizations. We can also recommend Kanban for many project contexts, especially since it is somewhat more lightweight and less rigid than Scrum. The V model is a process model for IT development projects in the Federal Republic of Germany. In the mid-90s, the XT version was published, which does without fixed processes and essentially only defines products, that is, artifacts and activities, that is, subtasks in software engineering that use products as input and output. Individual process models can be configured from these. In this sense, the XT stands for extreme tailoring. The products concretize the basic process model, which largely abstracts from the description of artifacts. The activities are either already inherent, thereby partly named somewhat differently, or likewise possible meaningful concretizations. The public sector in Germany prescribes the use of the V-Model XT, and efficient and effective agile software projects can also be configured with it, provided, as always, you know what you are doing.